Okay, let's get into more advanced stuff now. And for that, we'll be using a fascinating example use case from the world of decentralized finance, stablecoins. A stablecoin is basically a coin that is running on a blockchain that is stable. Surprise, surprise. Meaning stable in price. So, for example, it's always worth $1 and never changes in relation to the so-called peg. So, in our example, if we want the coin to be always worth $1, we say it's pegged against the US dollar. And you can either have this in a centralized way. So, this is, for example, the case for Tether, which is USDT. And for USDT, basically, there is a service where you can just deposit US dollar and they give you the digital coin for it. The actual US dollar you deposit is called collateral. The central service provider will give you a guarantee that you can always redeem your digital USDT to receive a full original US dollar back. This guarantee is what ensures the price stability. But it's obviously completely centralized. It's just one provider doing it. But there are also some decentralized stablecoins. And there are different ways decentralized coins are implemented. We do have an issue though for decentralized stablecoins. Of course, we cannot deposit real US dollar. How would you allow bank transfers in a decentralized way? I mean, I wouldn't say it's technically completely impossible. Maybe one day in 10 years, banks will have their entire infrastructure built on blockchain technology, and then it becomes possible, but it's clearly not possible now or anytime soon. Any bank account transfer requires central controls on sender and receiver side, not to mention the full control of the bank over all funds. So, what do we do instead? Well, in the world of Ethereum, we have, of course, decentralized funds. So either Ether directly or some other ERC20 token. So we can allow, for example, Ether to be used as collateral. What's the problem we then run into? Well, the price of Ether changes all the time. Let's say you deposit 1 Ether, and now at the time of deposit it's worth $1,000. So you get 1,000 of the stablecoin, and the collateral in the smart contract is worth $1,000. But now Ether drops in value to only $900. Now you still have 1,000 tokens of the stablecoin, which is supposedly worth $1,000. But if you wanted to redeem it and get Ether back, there's only 1 Ether worth $900. So now you see the stablecoin is not fully backed by the collateral anymore. And that would mean that also the stablecoin kind of loses its value. It's only worth $0.9 now. That's not what we want for a stablecoin. So what's the solution? Well, the idea is we can over-collateralize the stablecoin. So when you deposit 1 Ether at a price of $1,000, you get only $500 worth of the stablecoin, or whatever ratio is defined by the system of the smart contract. The point is, we have some safety margin for when the prices fluctuate. And then when the value of Ether drops, there's usually some mechanism to incentivize people putting in more collateral or burning their stablecoins. The exact mechanism for this can vary between coins. Some are even algorithmic stablecoins that buy or sell the stablecoin on the open market from an algorithm directly. So there are many ways to do it. Let's explore one way ourselves in the next chapter, and then we will actually even implement this as our first proper project.